1 gear, 1 bolt, 1 lead screw, 1 motor. This is the full build video. Our story begins with the metal frame of an old box fan. I cut up the sheet metal into different strips so I can use it to make a certain bracket that I will need for the rails. Then I make these aluminum biscuits, which will also be used for the brackets on the base. I round off the corners and then mark them all at the same points. That's why I had them between those two pieces of wood. Then I cut plywood strips, which I will need to create tension between tubes on the base. Here I am gluing up the special strips with selected raised areas. The areas that are not raised will be used to accommodate the metal biscuits and the sheet metal bracket. Now I am making star-shaped handles on the drill press by drilling 4 holes for each handle. I cut them apart on the bandsaw. Here I'm demonstrating how the mechanism will expand as I screw and unscrew the handle. Look at that, we're going to crimp the nut in there. And it works without fail. See, now the nut's not going to turn. Now I go about making the wooden tubes, which the rails will slide into. I start with 2 half-inch strips on the side and a 1/4-inch strip on top and bottom. Then I screw and glue everything together to make a super solid connection. With this cut open tube, when I push the rail in and I turn the handle clockwise, it locks the handle in place. When I turn the handle counterclockwise, it unlocks. Next, I am cleaning up the workspace and I am making more rails for the base. Those oak rails, which I glued and screwed onto the bottom of the expanding rails, will add extra support. As this is the only method that the rollers will be attached to, they need to be strong. Then I cut out a notch to correct for the sheet metal bracket, which protrudes out slightly beyond the height of the bracket. Now I am assembling the base using pine wood rails on top and bottom. Making sure everything is square is very difficult. Now I'm gluing rails onto the bottom of the existing rails so that I can attach roller skate wheels via bolts, which will act as the rollers to keep the Sandtronix 3.0 from driving off the end of the beam. I will use another set of aluminum biscuits and another expanding rail, which will allow the bottom plate to be adjustable side to side. This is important for balance, especially when I'm adding in motors and heavier components into the future. Here I'm making more star-shaped handles. I drill a hole slightly smaller than the head of the bolt, then I press it in using a vise. I made more of those sheet metal brackets using the rail from an old air conditioner. Now it's time to start making the gearbox. Print out templates for all the gears I will need, and I glue them to a piece of plywood. You can save time and energy by screwing together sheets of plywood. That way you get 2 gears for the time it takes to cut one. This wouldn't work when you want to do beveled edges on the gears. So here I am marking exactly what I need to cut away on these oak blocks. That's better. Alright, let's figure this out. Okay, so that bit was 5/16. I'm enlarging it to 21/64. These will allow bolts to be inserted, so I can assemble and disassemble the gearbox later. As you can see, those holes lined up perfectly. This is the speed change mechanism. It uses the same principle of rocking a gear back and forth to mesh against a bigger gear. Really? Knew that was going to happen. Here I'm hammering the shaft through the set of gears. It's always difficult to get this perfectly straight while hammering or clamping it in. Here I'm assembling the speed change mechanism. Here I'm adding spacers to ensure the gears don't slide where they're not supposed to. And here you can see the finished speed change mechanism. This doesn't allow for drastic speed changes, but it does allow for some speed change. Now this is the reverser mechanism. First speed forward, first speed reverse, second speed forward, second speed reverse. Now I have to make that through shaft spline, which will carry torque from the gear reduction mechanism to the reverser mechanism and speed change mechanism. I'm drilling holes in this washer so I can bolt a piece of metal to make a type of truncated D shaft. I ground that shaft down in the belt sander. Can you spot the hidden Mickey in this picture? This bracket that I just assembled out of way too many pieces will serve as a hold for the front sander carriage mechanism, and I used oak to give it maximum strength. Across the 3 Sandtronix prototypes I've built so far, the design for the sander carriage has remained virtually unchanged. These are the linear drawer slides that will hold the sander in place and allow it to slide freely back and forth. I want to mount a bearing like right here. It needs to be flush. I put in a 1/4-inch piece on top of that. I want to do the same thing, mount the same bearing in the same place on this one, but I need a different set of shims. So here I am trying to figure out exactly how I'm going to connect this axle right here to a shaft which is going to be underneath this wooden part. So I have a paper cutout of a gear here, which is the same size as this, very close. I made this oddly shaped box with box joints in all dimensions, which will act as the wing, which not only holds the front sander carriage in place, but also supports the motor. I use that plastic bushing to sort of center the drill press. This is my best attempt I can do at trying to drill a hole in exactly the center of the shaft. I needed this hole drilled in the center of the shaft because otherwise the bearing would be too big and it would run into the beam. Here I am making the rear roller mechanism, which will be height adjustable. Boom. Now I can loosen it. Boom. This one is like 3 pounds. This one, oh, it's 15 pounds. These are the motors that I'm considering to use to power the Sandtronix version 3.0. This is what I had powering the Sandtronix version 2.0. Let's see how they run. Both of these motors each weigh about 15 to 20 pounds. I'm disassembling the whole thing for fit and finish of the internal bearing and shaft spacer assemblies. First need the wrenches, like a ratchet with 14 half-inch, a driver with a 1/4-inch socket adapter on it. Also we'll need 10 millimeter. Start with loosening that bolt. Then I'm going to loosen the bolt on the other side. I'm going to unbolt this hinge. And this just slides out of the end of the roller, like so. This is bolted on here, but I think I can just leave it. I will unbolt the motor for ease of access. That is a 1/2 inch. Now there's one 10 millimeter bolt there, which I will undo. And now to release this entire wood piece on the side, I just need to and as you can see, the robot is coming apart. Next thing I'm going to do is release. This whole thing just comes right out. This is the main gearbox. Take off this bolt up here. This one up here is also needs to come out, and it is a 1/2 inch socket on this side. This front bracket is held in with 3 bolts. I believe that's also 1/2 inch. As you can see, this bolt doesn't come out the way it is, so I'm going to loosen this adjustment knob. 8 millimeter bolt. There's 2 little bolts here. Assemble this. Alright, and now the entire panel comes off. There's another bolt right here, which I will remove. These all need washers too. That's why I'm removing them. On this side, you have 2 of those identical bolts, but they're a little bit harder to get to. These are 1/2 inch. is some spacer action. Having spacers is very important to make sure everything runs smoothly. So this is why it's important to secure the bearings, especially this one. So the way I do that, as you can see on this one, is I put a screw next to it with a washer that overlaps. So right here, I have the base of the Sandtronix version 3. And whenever I go to bolt it together, I have to put the bolts in here. And then I have to hold the nut with a socket in the hole. And that doesn't matter once the device is assembled, but for now I want to be able to take it apart faster, more efficiently. There's boards in the way, normally, that would impede the ability to get a socket in there. So what I'm going to do, epoxy the nut in here. Epoxy the carbon. Drippings. And here's a bonus tip. If you ever have too much epoxy left over from what you're doing, I like to epoxy 2 pieces of plywood together. It comes in handy when I need to make something like a handle. Here we are the next day. What I'm doing here is one of the most important steps of building the sanding robot. I add the front pressure rollers, which apply downward pressure to the beam. 45 pounds, or half of 45 pounds, is too much for one sander. So I kind of freehanded this angle here on the sheet metal, but it's close enough. Here I'm taking a break from the sanding robot to build a toolbox I will need to carry the tools that I might need to fix it when I bring it on the road in a few weeks. At first I went with this clicking ratcheting mechanism, but this didn't offer enough options, so I used a screw to unscrew and rescrew a threaded rod. One of the trickiest parts of this whole build was deciding how I was going to move the sander back and forth. Initially, I used this ratcheting mechanism, which only allows for 3 or 4 positions to be used. So eventually I went with a threaded rod, which moved the sander back and forth laterally. After months of planning, building, and recording, I finally had my first full test. One of the updates I quickly made was to mount the dust collector on the sanding robot itself. I simply mounted a pole to the sanding robot and added some wire, which held the bucket in place. This meant only an extension cord need be connected to the sanding robot. This made it much easier to maneuver around from place to place. That's the end of this video. Next time, you'll see how I computerized the sanding robot over the course of the summer.